Now, welcome to the next lesson, which is indices and logarithm. And before I continue with indices and logarithm, I want you to understand that this is a way we are giving back to the society, mathematics. So, what you need to do, ask yourself, how can I give back to the Kenyan child? The only way you can give back to the Kenyan child is by subscribing and liking that video so that that video will go to the next person. And if you are done with the education, or you are doing it for 4 system, you can also make a contribution to the next generation. So subscribe. Now, indices and logarithm. And under indices and logarithm, we are looking at the indexed form of numbers. Remember, indexed form of numbers. Under indexed form of numbers, I want us to move slowly by slowly. Step by step, let us consider. Let us consider the number 32. And I want to call your attention to a certain lesson we did in this channel. That lesson was expressing a number as a product of its prime factors, prime factorization. So let us express 32 as a product of its prime factorization and see whatever we have. So, solution here, we have 32, then you ask ourselves, what is the smallest prime number that can divide 32? The smallest prime number that can divide 32 is 2. So 2 divide 32 how many times? 16. 2 divide 32, 16 times. The next prime number, still 2 can divide 16. So 2 divide 16 how many times? 8. The next 2 divide 8 how many times? 4. The next 2 divide 4 how many times? 2. Then 2, 1. So 32 expressed as a product of its prime factor is 2 times 2 times 2 times 2 times 2. So we can say 32 is equals to 2 times 2 times 2. How many 2's do we have? 1, 2, 3, 4, 5. Times 2 times 2. So this is a number expressed as a product of its prime factors. Now, we are tired of this repetition. We don't want to do this repetition. What are we going to do? We can count how many 2's do we have here, or we are multiplying 2 by itself how many times to give us 32. It is 1, 2, 3, 4, 5. So we can say this is equals to 2. Then we say we are multiplying it how many times? 5 times. That 5 we write it on top here. So you see where we are writing it? 5 we write it on top here, 2 we write it down here. So this number, so this form is referred to as power form or indexed form. So this one is read as, how do we read this? 2 raised to power 5. 2 raised to power 5. So in short we can say the power to which a number is raised is 5. 2 form now the base. Index. So we say that the power, note here and say the power to which a number is raised. The power to which a number is raised. The power to which a number is raised. The power to which a number is raised is called index. So we called index. Index, that is now singular. Plural, we have indices. So index when it is 1. Plural, when there are many, we call them indices. So this is whatever you need to understand. So here, in this example here, we have 2 is now the base and 5 is the power. So this 5 is the index. 32 is written in index form as 2 raised to power 5. 32 is written in index form as 2 raised to power 5. So this is what you need to do. I'm recalling your attention to the topic, the subtopic we did, which is now prime factorization. We are expressing a composite number as a product of its prime factors. And this is whatever we are doing here. And we are using prime factors only. But in index form, it is not a must for it to be prime factors. I wanted you to understand whatever we are talking about. 32 is written as 2 times 2 times 2 times 2 times 2, which is, we are tired this repetition. 1, 2, 3, 4, 5. Why should we repeat ourselves if we can know we are multiplying 2 by itself 5 times? What are we going to do? Instead of repeating ourselves, we just write 2 and the number of times it is multiplied. So 2 forms the base and the number of times it is multiplied forms the power. So that is expressing a number as a product of its prime factors in power form. Also, it is referred to as index form, and we have now defined index. We say that the power to which a number is raised is called the index when it is 1. Indices when there are many. As simple as that. So let us consider an example 1 here. Example 1. So we need to know, I said that, express the following numbers in index form. Express in index form. We are expressing in indexed form. A, what do you have? We have 3 times 3 times 3. B, we have 5 times 5 times 5 times 5. How many? Times 5. Then C, what do you have? We have 3 times 3 times 4 times 4 times 4. Then D here, we have A times A times A times another A. So these are now the examples we're being told to express these expressions or these numbers as a product, not as a product, in indexed form. We want to just write them in index form. If you are given this question, what are we going to do? You start by saying solution, S-O-L-N. You are solving. A, we have 3 times 3 times 3. 3 times 3 times 3. So here, we are going to say 3 is multiplied by itself how many times? So the number we are multiplying is 3. Then I count the number of times 3 is multiplied. That is 1, 2, 3. That 3, I write it on top here. So that is the power 3, the base 3. Here, 5 was the power. So the 5 here is the power. And 2 here form what we call the base. So 5 is the power, 2 is the base. Here, the power is 3. The base is 3. So the base is the number we are multiplying by itself. Don't forget that. The base is the number we are multiplying by itself, and the power is the number of times we are multiplying a number by itself. The base is the number we are multiplying by itself. Then the power is the number of times we are multiplying that number. So 3 times 3 is 3 raised to power 3. So it is read as 3 raised to power 3. Then B here, what do you have? 5 times 5 times 5 times 5 times 5. So, how many 5s do you have? 1, 2, 3, 4, 5. Here, 1, 2, 3, 4, 5. The 5 is multiplied by itself how many times? 5 times. So, the number we are multiplying by itself is 5. It will form our base. The number we are multiplying by itself, which is 5, will form our base. Then the number of times 5 is multiplied. 1, 2, 3, 4, 5. That's now 5 times. So it is read as 5 raised to power 5. 5 raised to power 5. Then come to C here. See, we have 3 times 3 times 4 times 4 times 4. So what do you have here? We have two different two different factors here. So we have 3, 3, then 4, 4. We are multiplying. So we are multiplying 3 by itself how many times? 2 times. I write 3. The number of times I'm multiplying it, that is 2. I write it on top here. So it is 3 raised to power 2. I'm multiplying by. Then 4 here. 4 is multiplied by itself how many times? 3 times. So what am I going to have? I'm going to have 4. How many times? 1, 2, 3. 3 times. So that is now 3 raised to power 2 times 4 raised to power 3. D, what do I have? A times A times A times A times A. So the base, what is our base here? The number we are multiplying, which is A. Then what is our power? The number of times we are multiplying A. The power, the number of times we are multiplying A. Then the base, the number which we are multiplying, which is A. You need to understand that. So I'm multiplying A will form our base. The number of times A is multiplied will form our power, which is 1, 2, 3, 4, 5. So this is now A raised to power 5. So it is written as A, the base, 5 the power. Read as A raised to power 5. 3 raised to power 2 times 4 raised to power 3. 5 raised to power 5. Then we have 3 raised to power 3. So it was just that simple. The shortest way of writing, the simplest way of understanding indexed form of numbers. Number 1, what is an index? The power to which a number is raised. So here 5 is the index, here 2 is the index, here 3 is the index, 5 is the index, 3 is the index. Then the number we are multiplying by itself a number of times form the base. Here 3 is the base, here 5 is the base, here 3 is the base, 4 is the base here, and A here is the base. You have to understand that. So we have learned now, and we know how to express a number as a product of its prime factor. Also, we have also learned how to express a number in indexed form. Now, example 2. I want you to get this one clearly. Example 2. Example 2. What are being told? Write each of the following numbers in its simplest indexed form. Write in its simplest index form. So here we have simplest, meaning that we have to ensure the factors we are going to multiply here by these factors multiplied by themselves are prime factors. As simple as that. Prime factors. So A we have 8, B we have 81. 8, 81. Now, solution. A we have 8. So we are expressing 8 as a product of its prime factors first. So let us do it somewhere here. 8, we can remember. The smallest prime number that can divide 8 is 2. 2 divide 8 how many times? 4. The smallest prime is 2 can still divide 4. And we talked about prime factorization, and we said first we need to check if this number can still be divided by this one before we move to the next prime number in ascending order. So 2, which is our prime number, can still divide 4, 2, then 2, 1. So 8, this is equals to 2 times 2 times 2. So 2 times 2 times 2 give us 8. Very good. Now, in index form, here we are having the number multiplied, which is now forming our base, 2, then how the number of times this number is multiplied, which is 1, 2, 3. 3 times. So it is 8 can be expressed as 2 raised to power 3 in index form. Then B here, we have 81. 81, I'll have 81 here. The smallest prime number that can divide 81 2 cannot, because a number is divisible by 2 if the last digit is even or 0. So let us try 3. Divisibility of 3. How can you tell a number is divisible by 3? The sum of the digits must be divisible by 3. 8 plus 1, that is now 9. Okay, so it is 3. 3 can divide 8 how many times? 3 divide 8 2 times, bringing 6, remainder 2. Into 21, 3 divided 21, 7. 2 plus 7 still 9. 3 can still divide this. 3 divide 27 how many times? 9 times. Then 3 divide 9 how many times? 3. Then 3 divide 3, 1. So 81 is expressed as 3 times 3 times 3 times 3. That is 81. Expressed as 3 times 3 times 3 times 3. 1, 2, 3, 4. We are multiplying 3 by itself 4 times to give us 81. But we are told to express it in index form. Index form. So what do you have here? We're going to have 1, 2, 3, 4. That's the number of times you're multiplying by 3. But the number being multiplied, that is now 3. So this one will form our base. Then 4 will form our power. That is now 3 raised to power 4. Read as 3 raised to power 4. 81 is 3 raised to power 4. So that is now indexed form of numbers. That is how we deal with indexed form of numbers. As simple as A, B, C, D. As easy as A, B, C. Now, you, wherever you are, just work for me this one out. Now. Don't waste any time. We are learning, we have started indices and logarithm. I want you to understand this. So, I want you to express in index form. Express in index form. Express in index form. What do you have? A, we have 7 times 7 times 7 times 7 times 7. Then B, what do you have? We have 2 times 2 times 2 times 3 times 3 times 3. Express for me these two values as a not as a product of their prime factors, but express these two values or these two numbers in index form. Already we have prime factors here, so it is very simple. You identify which number is being multiplied, form your base. Then the number of times you're multiplying that number, form your power. Also do this. These are two different factors. You need to understand how they're being handled. So as I said before, this is the only way we can give back to the society. So you can also join the movement of giving back to all Kenyan kids by just doing a simple thing. Subscribing to the channel, Kenya Science. I joined Kenya Science to ensure that I also contribute to somebody's life. There are some people who cannot go to school for various reasons, but we can ensure that videos reach them or the lessons reach them so that they are not left behind. So each and every time, subscribe, like the video. If you like the video, algorithms will take the video to the next person. Let us see you in the next class.